Hello, welcome back to lecture 2, part 2. So we're going to continue thinking about how we're going to read and write within this idea of critical evaluation and start thinking about constructing a narrative, so constructing the story that your report will be about. So let me first of all start off with talking about cognitive bias. So this is something that affects a number of areas of our thinking when we're considering topics, and probably the most important aspect of this for us within this topic is the idea of confirmation bias. So this really means that we have an idea, as this cartoon suggests, and everything that we do unconsciously we actually search to reinforce that view. So we search for, we remembering, we interpret, and we focus on information that confirms the opinion that we already have. And you could see why this might be quite bad when we're looking at critically evaluating both literature and actually coming up to do our own experiments and get our own conclusions from our own work. So confirmation bias is widely recognized as a cognitive bias aspect. And of course, scientific methods should limit the effects of this bias when we interpret data. Though there's a link here to studies that show that it's not always the case, and that the strongly held opinions still push through if we're not careful. So there are many areas where confirmation bias can negatively impact on the quality of our research. And again, there's another silly cartoon at the bottom to illustrate another aspect of this. So first of all, when we plan our experiments, so we need to make sure that we plan our experiments. Remember, in the last lecture, we talked about a hypothesis, and what we want to do is either prove or disprove maybe our null hypothesis. Well, you want to make sure that the experiments you set up actually do that, actually give you a chance of doing that, because there's a danger with this cognitive bias that actually we only select experiments that are likely to support our hypothesis and don't actually give us a chance to either disprove the hypothesis, or it ends up at best with inconclusive results, and which means then it's difficult to make a decision on that hypothesis. So ask yourself when you do, or in this case, in this module, when you read other people's papers, ask yourself, okay, could the experiment have actually rejected the hypothesis? Did they give themselves a chance of actually rejecting the hypothesis? And searching for the literature. So when you're actually doing this work, okay, again, there could be a danger that you only search for evidence that supports the view that you already had. So you selectively choose the literature. And as I said, the cartoon at the bottom here is a kind of a nice illustration, a nice clear illustration of what that means when we're not doing a proper search for the whole literature. And here's another example. So confirmation bias, it could favor evidence by ignoring evidence that doesn't support your preconceived idea. So as I said, the cartoon here again shows a rather silly but illustrative example of where confirmation bias might come in. So overcoming the bias, overcoming this while we search for the literature, which is the main aspect of this module, because you won't actually be doing experiments, but please bear that in mind when you do start doing experiments. Okay, so as you acquire knowledge, as you read the literature, as you read papers, you will form opinions, and having an opinion is a good thing. Okay, and it's a necessary thing for us to move forward to look at the scientific literature. Opinions are good. But confirmation bias suggests that it may cause us to only seek sources that support the initial opinions that we have. So you must search for evidence that both against and for your existing opinion in order to demonstrate that you've read and understood the literature properly and fully, or as much as you can. and allow you to provide strong arguments when you're talking about the papers that you've read. So I think when you're reading these papers, just look out for that. Look out for, have they set up their experiment properly, or have they really biased it towards what they wanted to say in the first place? So you could imagine an experiment where you've got wheeled robots and legged robots, and what you want to do is you want to show that wheeled robots are better than legged robots. So you create an arena, you create an environment where you run both experiments for wheeled and legged robots, and that environment, for example, doesn't have large steps in it. Let's say that. Okay. So wheeled robots are quite good on flat environments and environments which have got small bumps in them. Legged robots maybe aren't so good in those, or not as good as wheeled robots. But when you start having large steps, then wheel robots could get into trouble and maybe not get up those steps, whereas legged robots could. So an environment you could set up if you wanted to show that wheeled robots were better, then you could set that up in a particular way, and the experiment would show that wheeled robots were better than legged robots. But actually you've biased it, so that's going to be that's confirming the conclusions that you wanted to make. So just look out for those sort of things when you're reading through the literature. Okay, now I want to talk about the narrative now. So the story of your, I mean, not your book in this case, but your report. Okay, so I want to talk about the narrative and how you build this up over time as we go through. So let's look at the outline of your report. Constructing a narrative. So that's the story. That's the thing that people will be reading. You want to make sure that your report flows, that it's got a kind of a start, a middle, and an end. You know, so a bit like a book, but obviously much shorter in your case. Okay, and everything that needs to be included is included, and is included at the right place. So what you don't want to be doing is keep referring to things that the reader is going to be reading later. So as much as possible, you want to put the right information in the right place, so people aren't forever jumping back and forwards when they're reading your report, and try and limit the amount of irrelevant information that's in the report. And understand the function of each section. That's what we're going to do now. We're going to look at each section in turn, just to give us a better idea of what each of those sections should be including and not including. So let's just recall the form of the assessment for this module. But as I've said there, it's many of the things we're going to talk about here are applicable to all reports and papers that you might write in the future. But for this particular report assessment, the report should be around about 9,000 to 10,000 words. It should be in an IEEE format, so you can look up what that is, and you can download formats for that for your documents, which is about 15 pages, I think. It's around about 15 pages. Again, here's the structure of the report that we saw in lecture 1. Abstract, introduction, literature review, identification of a gap in the literature, formation of potential solutions, ethical issues, further work, and summary and conclusions. So we'll look at each one of those in turn, just to give a bit of an idea of what should be included in those. Okay, so some general advice, first of all, about constructing a narrative. So start general, don't jump straight in there. And for a reader that isn't completely au fait with the subject, they might get really confused. So start general and get more specific and detailed as you progress through the document, Nothing should come as a surprise. So there's a sentence which is good to keep in mind when you're doing that. So when you're writing this, you should start off by telling the reader what they're going to read. Then you write the stuff that you want them to read, and following that, you tell them what they've read. So what's going to be read, the reading itself, what they have read. And if you keep doing that in appropriate ways for appropriate paragraphs or sections or chapters, if you're writing a much bigger document, then actually the readers should be really clear about what they're reading and why they're reading that. So this is a large part of the narrative, to get the right narrative, to make sure that it's right. So while I talked about a story, Of course, when we're writing scientific documents, it's not the same as writing a thriller, where of course you don't want to know what's happened until the end. In these things, you want to make it really clear. Okay, so the reader will generate expectations of what's to come, and what you don't want to do is to build that up, and then they're disappointed that they actually haven't read what they were expecting. So make sure you keep that. What's coming? This is the text. What you've just read. Summarize it, and that's a really nice way of constructing your narrative in a good way. Okay, so let's look at these sections. So I think we could divide the structure of the report up into 4 sections. So there's the abstract, introduction, literature review. So that's all the kind of the background. That's the background information to get the reader in the right place. Then we've got identification of the gap and the formation of the problem. So that's after you've read the literature, after you've constructed your arguments. This is now, okay, but I found there's a gap here, and I think this could be a way of solving that gap, or this is the way of delving into that gap. Then there's a smaller section on any ethical issues that the problem solution might have. And then there's the what should we do next? How do we move forward from this? And summarizing and concluding the report. So those 4 are kind of sections are good ways, I think, of thinking about your report. So let's start off by thinking about the abstract. So sorry, this is quite a busy slide. This is taken from Nature. So Nature is one of the, if not the top journal in science and engineering. So this is expanded more on the wiki. So the actual document is on the wiki, taken from the Nature thing. So this is their suggestion of what an abstract should include. So don't worry about the actual text on the right hand side here. That's not so important. So it's really looking at the text on the left and seeing and explaining what's going on here. So 1 or 2 sentences providing the basic introduction to the field, comprehensive to a scientist in any discipline. So really, this is to give an introduction to anybody, to make sure that they understand what this is about and why, and really why you're doing this. Then a couple of sentences to give a bit more background, so going a little bit deeper, focused a bit more to the discipline that you're talking about. Then maybe a sentence stating the problem that you're addressing in this paper, in this article, in this book, in fact, that you're writing, okay? And the sentence summarizing the main results. So as it suggests there, that might use the words, here we show, or something equivalent to that. Then a couple of sentences, 2 or 3 sentences explaining what the main results reveal in direct comparison, usually to some other people's work. So for example, it could say that the new power system on these robots show a 10% improvement over previously related results, something along those lines. Then 1 or 2 sentences to put the results in more general context. So this new power system will allow robots to work on Mars for an extra 2 days. So putting it in general context. And then a few sentences, 2 or 3 sentences with a broader perspective on really saying where the work might go. So what might happen in the future. So that's a really nice way of constructing an abstract. When you read papers, you'll find that many of them don't do this. They miss out some of these sections. But for now, this is a good way of thinking. And if you keep this in mind, I mean, keep this document somewhere and refer back to it when you're writing, then that's a really good format for your abstract. Okay, let's move on to the introduction. So the role of the introduction is really to establish what the report or the paper is about, and it should give enough information to set the scene so the reader understands the background and the context to the report. And it should, if you're using acronyms or specific terms, then you should try and introduce those in the introduction as well. So everything is clear before the reader then moves on to the main part of the report or the paper. And maybe you want to add the boundaries, include the boundaries into the introduction as well. So we're including this, but actually we're not going to be looking at this, for example. Okay. And then at the end of the introduction, you should have a very short paragraph which says what the report achieves. So what you'll be talking about in detail at the conclusions, but at the introduction, just a brief summary of what the report achieves is a good thing to put in the introduction. Right, this is the end of part 2 of lecture 2, and so here's a couple of tasks for the workshop. So what I'd like you to do is pick 1 or 2 papers in an area of robotics that you're interested in, that's something you find of interest, and consider for now just the abstract and the introductions of those papers. And thinking back to what we've just been talking about, do the abstracts follow the style suggested by nature? So that rather busy page that we looked at, it's on the wiki, so you can refer to it, you can download it from the wiki. Do the abstracts of the papers that you found, do they follow this style? Mostly, completely, not at all. I'm sure it will vary from one to another. Okay. And then in the introductions of these papers, okay, does it make it clear what the paper's about? Does it give enough background and context for you? Do you feel that you're in a good position to read the rest of the paper, having read the introduction? Has it specified any boundaries of experiments that they're doing, of work that they're doing? So this paper only looks at wheeled robots. This paper only looks at legged robots, for example. And does it specify what the work achieves? So does it talk about, and what this paper shows is blah, blah, blah. Okay. So have a look at those and we will discuss that in our next workshop. Okay, that's all for now, and we'll move on to part 3 next time. Okay, thanks very much.